Natural base E has a base of approximately 2.71. Think of that number as like pi. Pi goes on forever, it's an irrational number, just like base E. So if you want to think of base E as approximately 2.71, earlier we graphed functions that were base 2, and they went off like that. That's going to happen with this function too. It's just going to be a little bit different of a base. So here are some examples that I just want you to plug into your calculator, know how to use your calculator, graphing or scientific. So here is our function f of x equals e to the x. And we want to evaluate it for x equaling -1. So you say f of -1 equals e to the -1. So go ahead and enter that into your calculator. So most calculators have some little e button where the ln is, like e to the x, and then you put in -1. And you get approximately 0.367. Graphically, this will be a point on the graph for the exponential function at -1, 3.67. Next example, let x equal 0.25. So we say f of a quarter is e to the 0.25. Enter it into your calculator. Second e, what I have to do, and then 0.25. And we get approximately 1.28. So as an ordered pair on the graph, if we were to graph this function, it would be 0.25, 1.28. Next one, let x equal 1/2. So f of 1/2, e to the 1/2 power. And you get approximately 1.64, which is an ordered pair, 1/2, 1.64. On this slide, we're going to actually graph the exponential function base e. So to find the exponential base e, I'm just going to show you how to do this with an XY chart. So we're just going to create some ordered pairs. So we'll just pick nice numbers like starting with a 1 or a 0. So remember, you're evaluating the function for y equals e to the x. So I'm going to just choose the number 1. So I'm evaluating the function for e raised to the 1. We did that on the last slide. So e raised to the 1 is approximately 2.71. Now let's just do 2. That means e squared, which is 7.3. 7.4. We'll round it to the nearest tenths. Now let's go to 0. So anything raised to the 0 power is 1. Go to -1. And then we'll go to -2. E to the -1. Think of it as 1 over e to the 1, or 1 over 2.71. You don't need to do that part. You can use your calculator for it. You get a very small number, because 1 over a bigger number is 0.37. -2. E to the -2 is the same thing as 1 over e to the +2, which is 1 over 7.4. Getting even smaller, 0.14. All right, so let's take the time to graph these ordered pairs now. Let's bring down this. So we'll go over 1, up 2.71. That's about here. And then over 2, up 7.4. So 4, 5, 6, 7, 8. Probably should mark a few of these. So there's 2, 7.4. Here is 1, 2.71. Next one is over 0, up 1. And then -1, -2. Pretty small numbers here. All right, so now if we graphically connect those points, the graph looks like that. It's increasing over time. It has an asymptote horizontally, just like base 2 does at y equals 0. It has the same critical point of 0, 1 as a base 2 problem. It increases over time. It has the same domain, has the same y-intercept, has the same domain and range. And that's how you can graph a base E exponential.